Okay, let's talk about bonding in carbon compounds. So, carbon compounds are what we call organic compounds. So, compounds that consist of mainly carbon and hydrogen. So, first, let's talk about carbon specifically, since this is the main component of an organic compound. Carbon has 4 valence electrons. You can figure that out by looking at the periodic table. It's a group 4 element, so it has 4 valence electrons. And if you draw the Lewis symbol, you have carbon with 4 dots around it, okay, 4 individual dots, indicating that it prefers to form 4 bonds, okay. That's going to be the most stable. That helps it get an octet of electrons. In those 4 bonds, it can actually form different types of bonds. It can form single bonds, double bonds, or triple bonds. And so it will form whatever it needs to get 4 of them. And it'll form single or double or triple depending on what it's actually attached to and how many things it's attached to. Okay, so here's really your possible combinations of bonding in carbon, at least for organic compounds. Okay, and organic compounds where there's not some charge on the species, so just standard organic compounds. If you have carbon in an inorganic compound, it may not bond quite like this. Um, but it could have just 4 single bonds. That's kind of your simplest case. It could have 2 single bonds and a double bond, or 2 double bonds, or a single and a triple bond. All of those things add up to 4 total bonds, okay, that will pair with 4 of its electrons, giving it an octet, okay. Now, the most basic type of organic compounds are hydrocarbons. It's what it sounds like. It's just compounds that contain only carbon and hydrogen. Okay. Um, and really, you can break hydrocarbons down into a couple of classes as well. So we have what's called aliphatic hydrocarbons, and that would be alkanes, alkenes, and alkynes. And those terms, what it's referring to is what type of carbon-carbon bonds are in the structure. So when you have a structure that involves only carbon-carbon single bonds, then it's an alkane, okay? If you have a structure that has at least one carbon-carbon double bond, then it's an alkene. And if you have a structure that has at least one carbon-carbon triple bond, it's an alkyne, okay? So the alkenes and alkynes, they don't have to have every single carbon double bonded to the other carbons it's attached to. It just has at least one carbon-carbon double bond. And same with the alkynes. It doesn't have to have triple bonds in the entire structure, just at least one. Okay, and so those are basic types. Usually when we're talking about hydrocarbons, that's what we're talking about most often. But there's another type, and that's the aromatic hydrocarbons. And the aromatic hydrocarbons, they get that name because they have an aroma. So they typically have a nice smell. Okay, so I mean, all organic compounds have some sort of smell, but usually they're not great. Uh, but when they're the aromatics, they usually have a pleasant smell. And so those are the types of compounds that are used in fragrances and even flavorings. Um, they tend to have, an aromatic, or they're classified as aromatics. And really that is based on, or it's due to kind of the structure within it. Um, excuse me. An aromatic compound always contains what we call delocalized bonds. And delocalized bonds are when you have electrons that are shared by more than 2 atoms. Okay, and really that's when you have some resonance in that structure. So an aromatic compound always contains some resonance in it. Now, not every organic compound that has resonance is aromatic. That's where it starts to get a little complicated. There have to be, some other criteria met, which we're not going to talk about. But the basic idea is you definitely have some resonance, whereas you don't have that in aliphatic hydrocarbons. You don't have these delocalized bonds that then cause this characteristic, this aromatic characteristic. Now, most often, at least when you're just talking about basic organic compounds, the types of compounds that are going to be aromatic are going to be compounds that contain benzene. Okay, they contain a benzene ring. So benzene is just a 6-carbon ring with alternating single and double bonds. And so you have 6 carbons in a ring, and you have those carbons attached by alternating double and single bonds. Okay, meaning that then they also have some H's on this ring. Okay, for those carbons to be bonding to 4 or having 4 bonds. Okay, so a benzene ring is really, it's C6H6 is the formula for a benzene ring. Okay, so you can just have a benzene ring, and that is an aromatic hydrocarbon. But a lot of times this structure is part of larger structures, and sometimes you even see it written in a shorthand where they just use lines, and so you'll see kind of this hexagon, and you'll have this alternating single and double lines. Okay, and that's a benzene ring. So when you see that structure, whether it's drawn out completely or shorthanded, even if there's things attached to it or it's part of a structure, then that's going to be an aromatic structure if there's a benzene ring in it. And so that's the most common type that you would run across if you're just in general working with organic compounds. And so this is, you know, something that you work with a lot in like biological and environmental fields, because, you know, what you're dealing with are living things which are made up of organic structures. So that's our most basic type of organic compound, contains only carbon and hydrogen. So those are hydrocarbons. But of course, it gets more complicated than that, because organic chemistry is a whole field of its own. It's pretty complicated. So I want to make sure you're aware of what else there can be. Okay. And so you can also have what we call a hydrocarbon derivative. Okay. And so that's the rest of the organic compounds, the more complicated ones. Okay. And so that's going to contain elements in addition to carbon and hydrogen. Okay. And so a lot of times it's oxygen or nitrogen or possibly both. You can also have halogens, occasionally like sulfur and phosphorus, things like that. Occasionally there's metals, but most of the time it's carbon, hydrogen, and then oxygen or nitrogen or possibly both. Okay. Now, the possibilities of the way that it's bond, there's usually some very specific bonding arrangements when oxygens are in an organic compound or nitrogens in an organic compound. And these common arrangements that come up in lots of organic compounds, we call them functional groups. And those functional groups, you know, all have specific characteristics. And so when you have multiple compounds that have the same kind of bonding arrangement that involves oxygen, they tend to react similarly. Or if they have the same bonding arrangement with this nitrogen atom, it doesn't matter what else is in that structure, that one portion of the molecule is going to react very similarly to other molecules with that same bonding arrangement. And so it's good to be familiar with, you know, some of these functional groups. And so I have a table here that gives you some of the most basic ones. Okay, there's more than this in organic chemistry, but these are the most common you would run across. And if someone thought you needed to know these would be the ones they'd think that at least you know these. And so alcohols, when you see an OH group coming off of like a carbon chain, those are pretty common compounds. Or ethers, you have an oxygen kind of in the middle of a carbon chain. Or you can have several different combinations where you have carboxyl group, a C double bond O. And so that C double bond O can be attached then to an H. It can be attached to just carbons on either side. It can have an OH group coming off, and so on. So there's lots of common arrangements. So here in this table, I give you 7 different ones. These are the most common you'd run across. Now, since this isn't an organic chemistry course, you don't have to memorize all of these, but if you were to go on to a course focused on organic molecules, you may have to know these. So it's a good reference for you to be able to look up and recognize some of these functionalities. And just realize the reason that we focus in on them is because that tends to be the part of the organic molecule that is reactive, and it's going to control what types of things it reacts with. So that's why that's important.